Alright, this is the very last video on fuel cells. I just want to go through the worksheet that hopefully I'll remember to leave you. So you will be expected to be able to analyze commercial fuel cell. There are so many different designs. We're not going to be able to go through all of them. You definitely don't need to memorize any specific example. You just need to know where to look. So I think I'm going to go through 2 examples, maybe 3, and see whether you can do the rest yourself. So the first type of, well, this is the second type of fuel cell that you're going to see today. The first one was acidic hydrogen fuel cells. This is an alkali hydrogen fuel cell. So always pay attention to the name. This is the fuel, which is also the reducing agent. And alkali mean the electrolyte is not acidic. So you probably can't use H plus to balance your half equations. So the way that you need to write the overall equation, the reduction, the oxidation, and then describe the flow of ions. Okay, I'm just gonna repeat these multiple times in the next 2 minutes, but the overall equation of a fuel cell, it's identical to the combustion equation between the fuel and oxygen. When oxygen is in excess, so complete combustion. So because the fuel is hydrogen gas, my overall equation is just going to be H2 gas plus O2 gas going to H2O. I'm going to go with liquid because it does say in the diagram that water outlet, so should be in liquid. You definitely need to balance your equation. So this is the overall equation. Even if you can't do anything else in a fuel cell, make sure you can write the overall equation. Okay. For reduction and oxidation, this is why we spend so much time balancing half equations last week. So if I give you an overall equation for a redox reaction under basic condition, you should be able to balance the half equation. So if you don't know anything else, and I'll show you there is a shortcut, but let's just do it from scratch. I'm going to find oxidation numbers. Hydrogen go from 0 to positive 1, so undergoes oxidation. So we go H2 to H2O. I'm just going to do it a little bit quickly. You're basically going to get something like this. The water is going to cancel out. However, because this is a basic condition, you're going to have to convert this half equation to basic by just neutralizing the H plus. So if I add 2 OH minus on this side and 2 OH minus on the other side, I'm going to end up with H2 gas plus 2 OH minus aqueous equal to 2 H2O and 2 electrons. So this is the final half equation under basic condition, which is the condition of this cell. For reduction, so you just write, so use cohes and balance the half equation under acidic condition, because you have H plus here, 2H2O. Alright, so this is the acidic condition. So once again, I'm going to neutralize the H plus by adding OH minus. Add the same amount of OH minus as you have for H plus, and then add the same amount on the other side. So you would have 4 H2O, and if we just cancel out H2O, I think I end up with 2 H2O left, because there's 2 on the right, so I need to cancel that out. 4 electrons equal to 4 OH minus IQ. Alright, so these would be the reduction and oxidation half equations under basic condition. Now, only for hydrogen as a fuel, and only since the start of the new curriculum, these 2 equations can actually be found in the data book. So both the acidic and basic condition half equations for oxygen and hydrogen gases can be found on the data book. So maybe take some time to find it, and next time you can just copy those 2 half equations. However, there are other types of fuels, so you still need to know where they came from. Okay, describe the flow of ions. Now the ion in this case OH minus, and anions go to the anode. You can even tell from the half equations, hydroxide is produced at the cathode and consumed at the anode. So if I need to draw something, it's going to be OH minus going to the anode. So that's my description. OH minus IQ to the anode. Okay, so that's the first example. I think I have a little bit more information here. This is a solution.